So section 4.5 is all about dividing polynomials. This is going to be a chapter where I will try and go as slowly as possible in these videos because I really want to make sure you understand every step that's going on and everything's just really clear. So when we're dividing by a monomial, what we do is we write our monomial as separate fractions. We can divide the coefficients and subtract the exponents. So if I had 15x cubed plus 3x divided by 3x squared, I would rewrite this as 15x cubed over 3x squared plus 3x squared over 3x squared. So 15 divided by 3 would give us 5. And then if I have x cubed over x squared, that just leaves me with 1x. If I had 3x squared over 3x squared, well, any number over itself is just 1. So that's how we're going to divide monomials. So let's go ahead and divide the trinomial 15x squared plus 20x minus 5 by 5, which we're calling our monomial. So that gives me 15x squared over 5, because what I want to do is pull this fraction apart, plus 20x over 5 minus 5 over 5. Well, 15x squared divided by 5 is going to give us 3x squared. 20x divided by 5 is going to give us 4x. And minus 5 divided by 5 is going to give us 1. So we're left with 3x squared plus 4x minus 1. So now let's take negative 12x to the 8th plus 4x to the 6th minus 8x cubed divided by 4x squared. So I want to go ahead and take negative 12x to the 8th plus 4x to the 6th minus 8x cubed. I'm going to write that over 4x squared. I'm then going to pull this apart into the fractions. Negative 12x to the 8th over 4x squared plus 4x to the 6th over x squared minus 8x cubed over 4x squared. Negative 12 divided by 4 gives me negative 3. X to the 8th divided by x to the 2nd gives me x to the 6th plus 4 divided by 1, that's still going to give me 4. X to the 6th over x squared gives me x to the 4th minus 8 divided by 4 is 2. X cubed over x squared just leaves me with an x. So I'm left with the degree 6 polynomial, negative 3x to the 6th plus 4x to the 4th minus 2x. Now I'm going to go ahead and again pull apart my numerator into fractions. So I've got 8xy squared over x squared y squared minus 9x squared y over x squared y squared plus 6x squared y squared over x squared y squared. This is going to give me, this first term is 8x to the negative 1. Y squared divided by y squared is 1. Minus 9, my x's cancel, but I have y to the minus 1. Plus 6, but my x squareds and my y squareds cancel. Now I don't like negative exponents. So this becomes 8 over x minus 9 over y plus 6. Now when you get used to this pattern coming about in monomial division, please don't feel like you have to write it out with negative exponents. If you realize you're going to have an x remaining in the denominator or a y remaining in the denominator, feel free to leave it there and skip a step. I write out every single step to make sure we all stay on the same page. Next, we need to talk about dividing a polynomial by a binomial. So the first thing you have to do is arrange the terms of both powers in the dividend and the divisor, the dividend being what we're dividing, in descending powers of the variable. Then you're going to divide the first term in the dividend by the first term in the divisor. Hi, Bobby. Yeah. The result is the first term of our quotient. Next, we need to multiply every term in the divisor by the first term in the quotient. Write the resulting product beneath them and subtract, right? You then bring down the next term, just like you brought down the next digit when we're doing long division of numbers. And you're going to use this new expression and, it's a lot of words, the new dividend, and repeat this process, okay? Until you get a remainder that has a degree less than the divisor. What does this mean? Well, here's an example of polynomial long division. Okay, what did they do? So they have their dividend, which is 3x to the fourth plus 12x cubed plus 7x squared plus 0x minus 1. And we're dividing it by the divisor x plus 3. So I say, okay, how do I make x look like 3x to the fourth? That's going to be by multiplying it by 3x cubed. 3x cubed times x gives me 3x to the fourth, and 3x cubed times 3 gives me 9x cubed. I then have to subtract this. My first term's always going to cancel. That leaves me with 12x cubed minus 9x cubed, so I get 3x cubed. Now I think to myself, okay, let's switch colors. What do I multiply x by to make it look like 3x cubed? Well, that's going to be 3x squared. 3x squared times x gives me 3x cubed, and 3x squared times 3 gives me 9x squared. I then subtract this. My first term cancels, and I have 7x squared minus 9x squared. That's going to give me a negative 2x squared. Now I think to myself, okay, what do I multiply x by to make it look like negative 2x from here? I'm going to multiply it by negative 2. Negative 2 times x gives me negative 2x, and negative 2 times 3 gives me a negative 6x. But I had 0x, that's kind of a placeholder. So if I subtract negative 2x minus 6x, that's going to give me a positive, because two negatives make a positive, 6x, and then I pull down my next term, which is a minus 1. So I say, okay, what do I multiply x by to make it look like 6x? Well, the answer is going to be 6. 6 times x plus 3 gives me 6x plus 18. I subtract. So my first terms are always going to cancel. Negative 1 minus 18 gives us a remainder of negative 19. So why don't we go ahead and do an example of this for ourselves. So I have 2x squared plus x minus 10 divided by x minus 2. So I can't write this as a fraction. I have to rewrite this using long division. So the first thing I do is I say, okay, what do I multiply x by to make it look like 2x squared? Well, that's going to be 2x. 2x times x is 2x squared. 2x times negative 2 is negative 4x. I then go ahead and subtract. My first term is going to cancel. I have minus a negative 4x, that's really plus 4x. So I'm left with 5x, and I pull down my next term. And I say, okay, what do I multiply 5x by to make it look like 5x? Well, that's going to be 5. 5 times x is 5x. 5 times 2 is negative 10. When I subtract this, 5x minus 5x is 0. Negative 10 minus a negative 10x is 0. So I have no remainder. Well, I have a remainder of 0. So 0 remainder. So 2x squared plus x minus 10 divided by x minus 2 gives us 2x plus 5. Let's work through another example. I have 3x squared minus 2x plus 5 divided by x minus 3. So I look at 3x squared and I say, what do I multiply x by to make it look like 3x squared? The answer is going to be 3x. 3x times x gives me 3x squared. 3x times negative 3 gives me a negative 9x. And then I subtract. My first term is going to cancel. So I have negative 2x minus a negative 9x. So that's negative 2x plus 9x, which is 7x. And I pull down my next term. Bobby, it is okay. We're dividing. It's all good. So next I look at 7x and I say, okay, what do I multiply x by to make it look like 7x? The answer is going to be 7. 7 times x is 7x. 7 times 3 is a negative 21. If I'm subtracting this, my first term is always going to cancel out. I have 5 minus a negative 21, so that's 5 plus 21. So I've got a remainder of 26. So I've got 3x plus 7, remainder 26, or 3x plus 7 plus 26 over our divisor, which was x minus 3. Now, for this one, remember we have to first put our terms from largest degree to smallest degree. So now I have 4x cubed minus 4x squared plus 7x minus 9. We're going to divide that by 2x minus 1. What do I multiply 4x cubed by? What do I multiply 2x by to make it look like 4x cubed? The answer is going to be 2x squared. 2x squared times 2x gives me 4x cubed. 2x squared times negative 1 gives me a negative 2x squared. I go ahead and subtract this. My first terms cancel. Negative 4x squared minus a negative, so that's plus 2x squared, leaves me with 2x squared. A negative 2x squared. I pull down my next term. What do I multiply 2x by to make it look like negative 2x squared? The answer is going to be negative x. Negative x times 2x gives me negative 2x squared. Negative x times a negative 1 gives me a positive x. I go ahead and subtract this row. My first term cancels. 7x minus x is 6x. And I pull down my next term. What do I multiply 2x by to make it look like 6x? Well, the answer is 3. 3 times 2x is 6x. 3 times negative 1 is negative 3. I go ahead and subtract this. My first terms cancel. Negative 9 minus a negative 3, that's going to be a positive 3. So negative 9 plus 3 is going to give me negative 6. So I get 2x squared minus x plus 3, r for remainder negative 6, or 2x squared minus x plus 3 minus 6 over 2x minus 1. Both these statements are equivalent. Our last example, I have 8x cubed minus 1 divided by 2x minus 1. Now, one thing I'm going to have to do here is I'm going to have to put in placeholders for every term. So I've got 0x squared, 0x minus 1 divided by 2x minus 1. And we're going to see why we need this in just a second. So what do I multiply 2x by to make it look like 8x cubed? The answer is going to be 4x squared. 4x squared times 2x gives me 8x cubed. 4x squared times negative 1 gives me a negative 4x squared. I subtract this. First term cancels. 2 negatives make a positive. So I've got a positive 4x squared. I then pull down my second term. And I say, okay, what do I multiply 2x by to make it look like 4x squared? That's going to be 2x. 2x times 2x is 4x squared. 2x times negative 1 is a negative 2x. I go ahead and subtract. 2 negatives make a positive, so I get 2x minus 1. 2x minus 1. What do I multiply 2x by to make it look like 2x? Well, the answer is just going to be 1. So 1 times 2x is 2x. 1 times negative 1 is negative 1. When I subtract, I have a remainder of 0. Okay? So that gives me that I have my quotient is 4x squared plus 2x plus 1.